Hi, my name is Komel Koansel, and I'm a PhD student in the Department of Energy Technology at Aalborg University. The title of this study is the effect of different alkali catalysts on hydrothermal liquefaction of biopulp with the recirculation of the concentrated aqueous phase, which is carried out in the Advanced Biofuel Research Group with the collaboration of my colleagues Thomas Helmer Petersen, Kamaldeep Sharma, Sakib Tor, and Lasse Rosenthal. To highlight the importance of taking care of worldwide municipal solid waste production, it is crucial to say that around 895 million tons of municipal solid waste is being generated in America, Europe, and Asia annually. It is noteworthy to say that USA itself is producing around 27% of annual municipal solid waste, a number around 242 million tons every year. Urbanization and increase in birth population are the two main reasons that can cause such a high number. By increasing the generation rate, the need for finding suitable valorization techniques is becoming urgent more than ever before. To find an efficient, environmentally friendly techniques, it is important to consider the composition of the waste. Even though with the help of valorization techniques like recycling, the non-biodegradable materials are being reused to some extent, there is no efficient technology to take advantage of the organic fraction, which literally is an important source of energy and chemicals. Just by considering waste wood, yard trimming, and waste food, around 35% of the whole municipal solid waste can be classified as the organic fraction that has the ability of producing specific chemicals and energy carriers. Here, some of the conventional disposal techniques can be seen in the energy and mass cycles. Due to the simplicity of treatment, landfilling and incineration have been the pioneers in treatment of municipal solid waste since many decades ago. However, based on the higher production rate of municipal solid waste and the disadvantages they can offer, thinking about an eco-design technique that can not only dispose of waste but also make value-added material out of that is in a great importance. The technology that we offer is hydrothermal liquefaction, which can effectively convert the biomass to a liquid energy-dense fuel in mild temperature and high pressures. However, in this way, some challenges need to be overcome. Due to the inefficient source segregation, the municipal solid waste always contains significant amount of non-biodegradable materials like plastics, metals, glass, and so on. To prevent any malfunctions during HDL process, the non-biodegradable materials need to be eliminated. In this regard, a mechanical treatment named as AIChE process was used to treat municipal solid waste in this study. With the integration of hydrothermal liquefaction, AIChE, and a refinery facility, it is potentially doable to close the CO2 cycle with the utilization of the produced waste in urban areas and generate a green fuel which is compatible with the existing infrastructure. Additionally, the separated non-biodegradable materials in AIChE process can be returned to the use cycle by employing a recycling facility. So now is the time to explain what exactly is AIChE and what does it do. AIChE process is a mechanical biomass pretreatment method that can effectively separate non-biodegradable materials like polymers, metal, glass with dilution of whole material in water and passing them through specific sieves using pressure. Separated organic fraction will be considered as a pre-prepared biomass named as biopulp, which contains 83% of moisture, 15% of dry matter, and only 1.6% of ash. It has been reported that the optimized dry matter content for biomass in a HTL batch is between 15 to 20%, while biopulp has already 15% of dry matter content, so it can be used directly in hydrothermal liquefaction without addition or removal of water. Based on the physical analysis, it contains considerable amount of cellulose fibers, which can effectively be degraded in hydrothermal liquefaction medium to the wanted substances. Since the ultimate aim is using biopulp in a continuous plant to produce fuel, it's important that the biomass is pumpable, therefore no clogging issue would be expected during continuous HTL. However, the negative point of biopulp is the microplastic that it has. Microplastics have been subjected of a lot of government restrictions in the recent years due to the perilous impact on environment and animals. Overall, it contains 0.27 gram of microplastic per kilogram of biomass. It is true that at the first glance it may seem a negligible number. However, multiplication of this number with the number that is mentioned at the beginning can face us with million tons of microplastics that can be spreaded in the environment if it won't be taken care immediately. Due to the harsh medium in hydrothermal liquefaction, we suspect that along with the biomass macromolecules, these microplastics can be degraded to high extent. However, it is not the main target of this study. As mentioned before, biopulp will be used in a batch hydrothermal liquefaction series of experiments to monitor its efficiency in biocrude production. Based on the previous experiments, two potential pathways are examined to increase the biocrude production yield. Catalytic hydrothermal liquefaction, in which we use four different alkali catalysts, including sodium hydroxide, potassium hydroxide, sodium carbonate, and potassium carbonate. The second way is the circulation of aqueous phase. However, since the biocrude already contains 83% of moisture, the aqueous phase will be evaporated to keep the dry matter content of the batch constant. Additionally, the effect of each catalyst on first circulation batch is examined. At the end, a full recirculation is done to thoroughly monitor the effect of concentrated aqueous phase recirculation on hydrothermal liquefaction of biopulp. The reference experiments were done in two parallel batch reactors, which contained 8 grams of biomass and 2 weight% of each catalyst. Non-catalytic experiment yielded around 30.6 weight% of biocrude, which can be considered as a promising biomass for hydrothermal liquefaction. Among all different alkali catalysts, potassium carbonate showed the highest efficiency in biocrude production. Sodium carbonate had also a positive effect on biocrude yield, while sodium hydroxide and potassium hydroxide did not increase the yield. Based on the mechanism proposed by UNEDA, the sodium carbonate and potassium carbonate catalysts are able to generate formate and hydroxide ions during reaction, which can ultimately act as the secondary catalyst and target the glycoside bonds of cellulose and hemicellulose and increase the biocrude yield. That is the potential reason for higher activity of the carbonate catalysts. Based on the elemental analysis, all the catalysts were able to increase the biocrude quality by deoxygenation reactions such as decarboxylation. Additionally, because of the pH elevation, all the catalysts suppressed dehydration reaction, which could form unsaturated compounds. To explain the lower biocrude production in the presence of hydroxide catalysts, two main reasons can come to the mind. The first, which will only happen in the case of sodium hydroxide, is the unrecoverable foamy layer that was generated. This layer was not recoverable neither in biocrude nor aqueous phase. Therefore, the carbon and nitrogen loss in sodium hydroxide case was higher than potassium hydroxide. Another reason can be the activity of this catalyst on production of light polar molecules that were soluble in water, so they did not recover in the crude phase and therefore the yield decreased. As can be seen, the highest carbon and nitrogen in aqueous phase was related to the sodium and potassium hydroxide cases. In the next step, a single concentrated aqueous phase recirculation was conducted where the extra water was removed using a vacuum rotary evaporator. The distillate phase can be returned to the AIChE process and be substituted by the fresh water. Recirculation of the concentrated aqueous phase has a positive impact on biocrude production in all cases, with enriching the biocrude phase with light oxygen and nitrogen containing polar compounds. From the Van Kervelen diagram, it can be seen that by single recirculation, the properties of oil change significantly and the oil absorbs more oxygen and nitrogen. As mentioned in the previous slide, single recirculation of aqueous phase enriched the biocrude with light organics. Therefore, the average boiling point distribution of the compound decreased. As can be seen in the TJ diagrams, after recirculation, the volatile matter increased, whereas the fixed carbon decreased. Based on the AIChE measurements, due to the concentration of the catalyst while recirculation, the AIChE percentage of the biocrude samples increased slightly. Moreover, after recirculation, the carbon recovery in the oil phase increased while using potassium carbonate as the catalyst. Therefore, potassium carbonate was selected as the most efficient catalyst and a full set of recirculation experiments were carried out. In this regard, after doing 4 consecutive recirculations, the biocrude yield became steady. This is probably due to the saturation of the oil phase by polar compounds. At the end, even though the higher heating value did not change considerably, the biocrude yield leveled up to 49.5%, and as energy recovery follows the yield, the energy recovery significantly increased. Finally, in this slide, you can see some take-home messages and some potential topics for future studies. Firstly, biopulp showed a great performance in hydrothermal process, and potassium carbonate had the highest efficiency in biocrude production among all the different catalysts that we examined. Single recirculation increased the biocrude yield in all catalytic and non-catalytic experiments. However, it enriched the biocrude with nitrogen, which is the negative part of this recirculation. And recirculation of concentrated aqueous phase in the presence of potassium carbonate significantly increased the biocrude's energy recovery. And for future topics, I would say that investigation on the effect of hydrothermal liquefaction on microplastic and inorganic distribution of biopulp, which are ongoing in our research group, and eventually the effect of catalyst adjustment while circulation of the concentrated aqueous phase can be studied in next studies. Thank you for your time and attention. I will be glad to answer if you have any question. But anyway, you can always feel free to contact me with my email and also LinkedIn and ResearchGate accounts.